We are live. So here we go. Number one, we are going to do 5 square roots of 32. So this old stuff. A couple of ways to make 32. There's 4 and 8, but I'm going to go and make it 16 and 2 just because it's a faster multiple. 16 times 2 is 32, but there is a square root of 16, which is 4. So I'll take the 5 times the 4, which makes 20 square roots of 2. That's all I got to do. Okay. Number 2. And slow me down if I get going too fast, all right? Chris, you can see it back there? Good, okay. Number 2, we have 5x square roots of 10x to the 5th. Okay. Can't do anything with 10. 10 will not break down, but I can do something with the x to the 5th. What I want to do is make this an even number, so I can take half of it. So I'm going to rewrite it as x to the 4th and x. So I take 1 away from it, so I can make it even, so I can take half of it, okay? So now, can't take the square root of 10, but I can take half of that. If I take half of that, I get an x to the 2nd, because I take half the exponent. 10 I can't break down. The x is left over, so it's just square root of 10x. Finally, 5x times x makes a 5x cubed square roots of 10x. Okay. Okay. Grace, I took 1 away from that, which makes it 4 and 1. The reason I do this, I can take half of it, so I need an even number. Okay. So took half that, gave me an x squared, okay? Alright, let me keep going, and Grace will be happy to give this to you when I'm done. We can look at it later, okay? Okay, number 3, square root of 49 over 81. This one's really simple. It's just 7 over 9. That's it. That's it. That's it. Pretty easy, huh? 4 is a little different because we don't have perfect square roots, but we've got the square root of 8 over 7. So I'll rewrite it as the square root of 8 over the square root of 7. Okay, this one's going to take a little bit more work, but we can do it, okay? 8, I got to break down 8. Let's make the square root of 4 square root of 2. Okay, because I want to break down my 8. Square root of 4 is a 2, right? So I'll have a 2 square root of 2 over the square root of 7. Yeah, thank you. Okay, now, I'm not done yet because I can't have a square root in the bottom. So I'm going to multiply top and bottom by the square root of 7, square root of 7, which gives me a 2 square roots of 14 over 7. Now, you want to know where the 7 comes from? 7 times 7 is 49. Square root of 49 is 7. Okay. Okay, moving on. Grace, let me know when you're good. I'll write it down while I'm waiting. 5 is 4 square roots of 5 times 3 square roots of 15. Okay, slide over. Okay, so multiply regular numbers with regular numbers, square root numbers. I'll have 12 square roots of 75. I'm going to break down 75. I'll have 12 square roots of 25, square roots of 3. Square root of 25 is 5, and 5 times 12 is 60, square roots of 3. There you go. Okay, I'm going to flip my page. You ready? Okay, Zane, can you see it way back there? You good? Flip the page. Let's look at number 6. Okay, number 6 is very similar to what we just did, except it's got x's in it. I'll go a 4x cubed square root of 2x times a 2x square root of a 6x to the 5th. How's that? You got it? Thanks, Grace. Thank you. So let's multiply regular numbers with regular numbers, square root stuff with square roots, okay? So we'll get a 8x to the 4th, square root of a 12x to the 6th. Okay? Leave the 8x to the 4th alone. It's on the outside. 8x to the 4th. And I'll break up the 12. 4 and 3. And I'm going to take half of this. If it's an exponent, I take half of it. So I'll just make it a x to the 3rd. Okay? Square root of 4 is a 2. 2 times the 8 is 16. You okay with that? Square root of 4 is 2. 2 times the 8 is 16. And then I'll have an x to the 7th. X to the 7th. Square root of 3. Okay? That makes sense. Slide it up for number 7. How am I doing? Okay? Okay, 7. 4 square roots of 5 times 5 square roots of 5 minus 2. Okay, I'm just going to distribute. I'm going to go this times this, this times this. So I get a 20 square roots of 25 minus 8 square roots of 5. And there's more I can do. Square root of 25 is 5, so I got a 20 times of 5 minus 8 square roots of 5, because I can't do anything with that. 20 times 5 is a 100 minus 8 square roots of 5. Okay. I will wait. And we'll do number 8. I'm waiting on Grace. Which is okay. Nothing wrong. It's okay to wait on Grace. 8. Parentheses. 2 square roots of 7 plus 1 times 7 square roots of 7 minus 1. Okay, I'm going to FOIL. Right? First, outside, inside, last. So 2 square roots of 7 times 7 square roots of 7 is a 14 square roots of 49 minus 2 square roots of 7 plus 1 square root of 7. Nope, 7 square roots of 7. 7 square roots of 7 minus 1. Okay. Now I can do more. I can go to the square root of 49 is a 7, so I'll have a 14 times 7. These two combine to make a positive 5 square roots of 7 minus 1. 14 times 7, I think, is 98. 14 times 7, 14 times 7, 98, yep, 98. 98 plus 5 square roots of 7 minus 1. I can put the negative 1 and the 98 together, make it a 97 plus 5 square roots of 7. And that's it. Okay. Thumbs up. You good? Alright, let's take a look at number 9. Yeah, thanks. 9. 9's actually pretty easy. You're going to like 9. 9's not hard at all. 5 square roots of 5 plus 8 square roots of 3 minus 6 square roots of 5. I can put these two together because they're the same to give me a negative 1 square root of 5 plus 8 square roots of 3. And that's all I can do because I can't add them if they're different, okay? 10. Got the square root of 27 plus 3 square roots of 48. So at first it looks like you can't add them because they have to be the same to add. But if I work on it and try and reduce them, they might turn out to be the same. So 27, that's 9 times 3. And 48, a good combination of 48 is 16 times 3. Now you could have used 4 and 8. You would have had to break it down again, but or 6 and 8. But eventually the best combination is 16 times 3. So square root of 9 is 3. Square root of 16 is 4. Okay. So I have a 3 square root of 3 plus a 12 square root of 3. And now I can add them because they're the same, right? Which gives me a 15 square roots of 3. Alright, slide it up a little bit. 11. Fourth root, 16x to the 12th. Okay, to be a fourth root, it needs something times something times something times something, right? Turns out to be 2. 2 times 2 is 4 times 2 is 8 times 2 is 16. So there really is a 4th root of 16. 4th root of 16 is 2. And then we're going to take a fourth, 1/4 of the exponent. So we're going to take a fourth of that, which is just x to the third. That's my answer. Let's see what I got for 12. Okay. 12. 4th root of 32, x to the 12th. It's almost the same kind of problem, isn't it? Except for there's no 4th root of 32. But there is a 4th root of 16, right? So what if I wrote this as the 4th root of 16 times the 4th root of 2? So what I'm doing is just finding a number within 32 that has a perfect 4th root. 16, right? I like 16. So, and then I'll still take the 4th of the x to the 12th. I'll still take a 4th of that and make that x to the 3, okay? I'll still take 1/4 of that. Okay, the 4th root of 16 is 2 with this x to the third. And then the 4th root of 2 is, that's all. Okay. Okay, number 13 was on our warm-up. I did it on purpose so we'd understand it again. Okay, I'm going to flip my page, okay? Okay, flip my page. And number 13. I've got the cube root of 3 over 25. Okay, so let me rewrite it as two separate roots, okay? Cube root of 3 over the cube root of 25. Now there's not a cube root of 25. What we saw earlier was that we could rewrite this as the cube root of 5 squared. Okay, the reason I want to do that is because what I'd like to have is 5 cubed. I really want 5 cubed because if I got 3 of them, then I can take a cube root of it. So I'm going to multiply top and bottom by the cube root of 5, cube root of 5, because that's going to really make a total of 5 cubed, and I can take the cube root of that. Now the top, the numerator, we don't care about that. We're just going to get the cube root of 15. Okay, a root on the top, denominator, so okay, but the denominator is going to give me a cube root of 5 to the third. And I got a cube root of a perfect cube, right? So just cancel it, make just 5. Totally right. So then on top, I'd have the cube root of 15 in the numerator, and in the denominator, I'll have just a 5, okay? Don't divide these. Do not divide that. That is not a 15. It's some ugly decimal number. Cube root of 15 is some ugly decimal in our calculator. Don't divide those, okay? Okay, because you won't get the right answer, okay? All right, 14. We're moving along. Okay, 2 ways to do 14. I'm going to show you both ways. 32 to the negative 2/5, right? If I have a negative exponent, which I do, it's going to be 1 over. I'm going to start right off the bat with 1 over. Okay? The 5th root of 32 to the 2 power. Okay? 1 over from the negative, 5th root from the 5 of 32 squared. Okay? So what is the 5th root of 32? Well, it's got to be something times something times something times something times something. Turns out to be 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, right? So the 5th root of 32 is 2. So I've got a 1 over 2 to the 2nd power, which is just 1/4. Now, you could probably do it on your calculator. Probably could. I mean, if it's just numbers, why couldn't we just use our calculator? So let's see how our calculator does it. We could put a 32 to the power of parentheses negative 2/5. Okay, there it is. No, it's not. I got the wrong. Okay, I'm dyslexic. 32 to the power of negative 2/5. There we go. Does that look better? And that is the question. Hey, you're back. How's Miss Murphy?
Miss Murphy was good.
Okay, you should be here, not with Miss Murphy. 0.25, which is 1/4. You guys agree? Same answer, okay? All right. Going. Let's look at 15, okay? 15 is a pretty easy one. 15 is 27 x9 y6 to the 1/3 power, okay? So here's what I'm going to do. 1/3 power is the same thing as cube root. It really is. Cube root 27 x9 y6. Okay? So the cube root of 27, what times what makes 27? What? 3. Right? 3. So the cube root of 27 is 3. Take 1/3 of my exponent. In fact, you can see why it's 1/3 up here, can't you? See why it's 1/3. x3 y to the 2. That was easy, huh? Okay. 16. Okay, here comes a fun one. 5 over 3 minus the square root of 5. Okay. Now, if you were to multiply, don't do it, by square root of 5 over square root of 5, it won't work, because you'd have to multiply the 3 by the square root of 5 also, and you'd still have a square root at the bottom. So there's a trick. It's called the conjugate. So whenever you get a plus or minus here, you multiply by a thing called the conjugate. It is going to be the opposite. It's going to be a 3 plus the square root of 5. And on the top here, we're going to go 3 plus the square root of 5. Okay? So it's just an ugly problem, but we're going to fix it, okay? 15 plus 5 square roots of 5 on top in the numerator. And on the denominator, we're going to have to FOIL. We'll get a 9 plus 3 square roots of 5 minus 3 square roots of 5 minus the square root of 25. Okay, I'll let you think about what I did, okay? I just FOILed. 9 positive 3 square roots of 5 minus 3 square roots of 5 minus the square root of 25, okay? Now, the reason we do the conjugate, this always happens. The middle two terms will always cancel. Always. That's why we do it. Yeah. There you go. So, when we do the conjugate, the whole point is to have this happen. And it will always happen when you do the conjugate, okay? And that gets rid of the square root, because the square root of 25 is just 5, right? It's gone. Right, Duncan? Yeah. So, we're going to have a 15 plus 5 square roots of 5 over 9 minus 5, right? Which is just a 4. So we'll have a 15 plus a 5 square roots of 5 over 4. And the square root on the top is okay. These two have the exact same value, but this one's written without a square root in the denominator, okay? Can you do that one tomorrow? Right? Yeah.
Oh, I wasn't listening.
Okay. Lane.
You can do all these on a calculator?
You can, but you won't get this answer.
You want that answer?
Oh, yeah. I know, sorry. Yeah, I do. Okay, turn the page. Number 18. This is an exception because you get 0.25, right? Which is 1/4. But you can't get a square, like for instance, square root of 3. If the answer is square root of 3, I wouldn't want that. Huh? Oh, what am I doing? 17, right? 17. Let's do 17. Thanks, Alondra. 4th root 81 over x to the 3rd. All right, let's break it up. 4th root of 81 over the 4th root of x cubed. Now there is a 4th. You know, you said 9, so you're close. And with 9, 3 times 3 makes 9. So watch, Londa. 3 times 3, 3 times 3. How many 3s did I say? So the 4th root of 81 is 3. It is. It's 3. So the 4th of 81 is 3. Okay, and you saw when you said 9, you were close, right? Now what about this? I need a 4 right here, don't I? I need a 4. I need an x to the 4th. What am I going to do to get an x to the 4th? Multiply by what? You guys are falling asleep on me. I can see it. Hang in there. Hang in there. Okay. So let's multiply by an x over an x, but a 4th root of x, 4th root of x. I'm going to get a 4th root of x to the 4th. I like that, because that'll make a plain old x, right? But I also have a 4th root of x here. So my answer, you ready? 3 times the 4th root of x over x. And that one's a little bit harder. We're getting there. Hold on. Don't fall asleep on me yet. Hold on. We're getting there. Okay. Number 18. See how close we are in a graph? Let me get a piece of graph paper. Okay. All right. Piece of graph paper. 18. Let's see if I can get this. I'm going to have a f of x equals square root of x plus 2 minus 1. Now, I like the way Becca said it the other day. She said the starting point, right, Becca? Becca said the starting point is at negative 2, negative 1, because it's the opposite, right? It's the opposite, so it's the opposite, so go to negative 2, negative 1, starting point. Now, we're going to do a square root. So I start here, I go over 1. What's the square root of 1? 1. Now, I'm going to go over to 4 from here, from the starting point. 1, 2, 3, 4, because the square root of 4 is
16.
2. Then I go over 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Arthur, what's the square root of 9? 3. Thank you. Okay, so the graph keeps going, but this is all we see of it. It looks like this. Okay. Now domain. Let's think about domain. Domain is how wide. It doesn't have anything back here at all, right? So the domain has got to be x is greater than or equal to negative 2. And the range is how high. It doesn't have anything down here, but starts at a height of negative 1. Y is greater than or equal to negative 1. Okay? Um, 21. We're almost there. We really are almost there. Okay, take this away. 21. All right, let's do 21. We are so close to being done. Let's get her done. Then we can take a break. 21. We've got square root of 2x equals 12. Okay. Right? Square both sides. Yep. 2x equals 144. You're right, Alondra. Divide by 2. Yeah. X equals 72.
I like these ones.
These aren't so bad. Okay, 22. Square root of x minus 5 equals 15, right? Square both sides. X minus 5 equals 225 plus 5, x equals 230, okay? These are easy, aren't they? Yeah. Be nice something easy. 23. We've got the square root of an 8x minus 5 equals the square root of a 2x plus 4. Square both sides, right? Got an 8x minus 5 equals a 2x plus 4. Minus 2x, right? 6x minus 5 equals 4. Plus 5, 6x equals 9. Divide by 6, and believe it or not, it is 1.5. 9 divided by 6, 1.5. Try it on your calculator if you don't believe me. 3 halves. Okay, alright. Okay, take this away. We are almost done. We've got 2 more to go. Okay, now the hard one. 24 is the hard one. It really is, but that's okay. We're smart. We can do it. 24. Here we go. We've got square root of x plus 18 equals x minus 2. Okay, well, what makes this one hard? Well, when you square both sides, you're going to have to square this, which means you really have to write it as an x minus 2 times an x minus 2. Okay, that's what makes this one hard. Because when you square it, it means multiplying it times itself, right? So then you're going to get a x squared minus a 2x minus another 2x plus 4. You got to FOIL it, don't you? Yeah. Add those two, x squared minus 4x plus 4, right? All of that work just so we can have it equal to x plus 18, right? Well, I got an x squared and I got an x. Looks to me like it's going to be the F word. Doggone it. We're going to have to factor, right? Minus x, minus 18, minus 18, right? 0 equals x squared minus a 5x minus a 14, right? But we can factor that, right? What times what makes 14?
7 and 2.
Yep, totally right. 7 and 2. Let's go negative 7 and a positive 2 because that'll make a negative 5. But we're not done since we're solving them. We'd set them equal 0 and solve them, so we just get the opposite. So we'd get a positive 7 and a negative 2. So our answer is positive 7 and negative 2. But always worry about negatives with square roots. So I'm going to throw out the negative 2. Can't use negative 2, just 7, okay? 25, we're almost done. 25 is easy. Honest. 25 is easy. I have x plus 5. Arthur, you ready? To the 1/3 power equals 4. You're always ready. Okay, 1/3 power, same thing as cube root. It really is. So the same thing as a cube root of x plus 5 equals 4. Okay? Cube it, right? Cube it. Cancel it out. X plus 5 equals 4 times 4 times 4, which is 64. Minus 5, x is 59. That is all she wrote.